With PortFast, a port transition does not trigger a topology change. You can configure PortFast using per interface or globally on the switch option. Configurations for these options are shown on the slide. Under the first option, configuration is done using per interface, while in the second option, all ports that are configured for access mode, non-trunking, will have PortFast automatically enabled. Let us now learn to configure Cisco spanning tree modes. To implement STP available in Cisco devices, use the command shown on the slide and specify one of the three options. The default is PVST. In the next slide, let us look into the Per VLAN Rapid Spanning Tree. Per VLAN Spanning Tree Protocol, PVST, is also called PVST+. This version supports one instance of STP for each VLAN. PVST can make use of redundant links by using them for other VLANs. A link could be blocking in one VLAN but forwarding in another. Note, the remainder of commands in the lesson is PVST commands. In the next slide, let us look into setting bridge priority. The bridge priority in per VLAN STP consists of the base priority plus the number of the VLAN. If you manually configure priority, use the base priority. The priority in show run is the base priority as well. However, the priority shown in spanning tree show commands is the actual priority. Note, range is 0 to 65,535, where default is 32,768 in increments of 4,096. To influence root bridge election manually, using this command would require checking all switches' bridge priorities to make sure that the lowest priority is configured. The root bridge can be specified with the command. Let us discuss this in the next slide. Setting the root bridge is the recommended method for influencing root bridge election. This command is actually a macro that sets the following values: bridge priority, max aging time set to 20 seconds, hello time set to 2 seconds, and forward delay set to 15 seconds. The bridge priority is discussed in the next slide. Using defaults, configuring the primary command will result in the last command on the screen being inserted into the running configuration. Let us continue our discussion in the next slide. The primary command influences the bridge priority depending on the priority of the existing route. If the existing route has a base priority greater than 24,576, set this switch's base priority to 24,576. Otherwise, the base priority is set to 4,096, less than the existing route's base priority. The result is rounded down to 0. Given defaults, this almost guarantees that the root bridge configured with the command will become the root bridge. Note, the setting can be changed after the macro runs in this or other switches. Therefore, using this command does not necessarily mean the switch will be elected as the root bridge. Do not assume the switch with the primary command has become the root switch. Check this with the verification commands. In the next slide, let us discuss the output from the show command. The output from the show command is displayed on the slide. Take some time to review it. The output is for VLAN 1. The second line says, Spanning Tree Enabled Protocol IEEE. This means the Cisco PVST STP was configured. The next line says, Root ID. All information in this section pertains to the root bridge, not the local bridge, unless it is the same. Therefore, the root bridge priority is 32,768, the default. The MAC address is the lowest for any interface on the root bridge. The cost is the root path cost for this switch. Here it is 38. If this is the root bridge, it will say, this bridge is the root. The root port is FA05. In addition, the timers on this switch use the default settings. The next group of settings apply to the local switch. Notice the priority is the default priority plus the VLAN number, which is 1. The timers on this switch are the default, as they are on the root bridge. Now let us look into the detailed information by interface. The port roles are listed. The root port, as we also saw above, is FA05. FA019 is designated and FA09 is blocking. The costs are listed by interface. FA09 is 10 megabits per second, and the other interfaces are 100 megabits per second, assuming defaults are used. In the following slide, let us discuss how to verify RPVST. This slide shows output when RSTP is used. This is configured with the Spanning Tree Mode Rapid PVST command. Note on the second line it says Protocol RSTP. This bridge is the root, so the root ID and the bridge ID information match, even though only the hello timer is used in RPVST. Max age and forward delay are still displayed. All ports on a root bridge are designated and forwarding. Let us look into the commands used to verify the blocking ports. Enter the Show Interfaces Trunk command. GI2/1 is a trunk, which was formed by negotiation. Negotiation is denoted by an N next to the encapsulation. The section for VLANs allowed on trunk includes VLANs allowed per switch port trunk allowed VLAN command. Out of those, VLANs 1 through 4094 are allowed. The next section shows that only a subset is allowed and active in management domain. That is, VLANs that are defined on the switch have ports assigned to it. It is possible not all these remaining VLANs are passing the traffic. This is because their interfaces could be in an STP blocking state, or the VLANs could be pruned by VTP, VLAN Trunking Protocol. Therefore, the only VLANs passing traffic through GI2/1 interface are listed in the last section. This show command is helpful in finding why a VLAN is blocked. Let us understand the methods to increase bandwidth in the following slide. There are several methods to increase bandwidth. One is to replace the link with a higher speed link. As you go towards the core, switches must handle the aggregation of the traffic at lower layers. Increasing the bandwidth on an access layer link may simply cause congestion at the distribution or core layer and not solve the bandwidth problem at all. Bandwidth can be increased by adding more paths. The problem is that Spanning Tree blocks redundant paths, as we saw earlier in this lesson. This means the additional paths would not be used even if they were available at layer 2. The best option is to use EtherChannel for link aggregation. You can add a few physical links, but they will look like one path to Spanning Tree. Let us look into the overview of EtherChannel in the next slide. EtherChannel is a Cisco proprietary technology for links fast Ethernet or above. The links must match in many different parameters, for example in speed and duplex. EtherChannel can be used to connect various devices to a switch. It can connect two switches using either access or trunk mode. It is also used to connect a switch and a router. The binding of the physical ports is called a channel group. A channel group, also called a channel, is identified by a group number. The group number is locally significant. It does not have to match on both ends of the link. In the next slide, let us discuss how an ether channel is established. There are three ways to establish an ether channel. The first is manually, using the channel group number mode on command. The other methods involve different types of negotiation. One is negotiation using Port Aggregation Protocol, PAgP, a Cisco proprietary protocol. This is the default negotiation method. Negotiation is also possible using Link Aggregation Control Protocol, LACP, an Institute of Electrical and Electronics Engineers IEEE standard. Let us look into the advantages of EtherChannel in the next slide. Following are the advantages of EtherChannel. EtherChannel can be used with existing switch ports. Most configurations are set on the EtherChannel itself, without too much configuration on the individual links that make it up. Spanning tree recalculation does not occur unless all the links that comprise the EtherChannel fail. Therefore, even if one redundant link is up, traffic goes through. EtherChannel provides load balancing, which means multiple redundant links can pass traffic simultaneously. In addition, various load balancing methods are available. An EtherChannel consists of 2, 4, or 8 active physical redundant links. Finally, one Media Access Control MAC address is used for the entire Ether channel, so it is compatible with all applications. The applications are not even aware of existing multiple links. Let us move on to channel group, number, mode, command, settings in the next slide. When PAgP is used, the two modes are auto and desirable. Modes for LACP are passive or active. These modes have the following effects. Passive or auto does not initiate negotiation. This is the default negotiation mode. Active or desirable actively seeks negotiation of an Ether channel. Without negotiation, an Ether channel can be created by specifying the on mode. If both sides are configured as on, an Ether channel is formed with no negotiation. Let us discuss PAgP and LACP negotiation in the next slide. Ether channel involves two interfaces. The linked interfaces can have any number of combinations of channel mode. These combinations result in an Ether channel or not. If both sides are configured as on, an Ether channel is formed with no negotiation. For PAgP, if one side is desirable and the other side is auto or desirable, an Ether channel is formed with PAgP negotiation. For LACP, if one side is active and the other side is active or passive, an Ether channel is formed with LACP negotiation. In all other cases, no Ether channel is formed. If PAgP or LACP negotiation occurs and fails, the interfaces will still come up, but not as a channel. In the next slide, let us discuss Layer 2 Ether channel configuration. This slide presents a configuration of a Layer 2 Ether channel trunk. In other words, Layer 2 trunk ports are bound together to create a channel. This code configures just one side of the channel. The other side is configured similarly. All interfaces that will participate in Ether channel are shut down, and then configured together as a trunk. The active parameter signifies that LACP negotiation will be attempted. The channel group number is 2. Since this side is configured as active mode, the other side must be active or passive mode to form an Ether channel. The port channel number matches the channel group. After configuration is complete, the underlying physical interfaces are brought up. In the next slide, let us discuss the Show Ether Channel Summary command. An example of the Show Ether Channel Summary command output is shown on the slide. In the output, there are two channel groups. One is a Layer 2 Ether channel negotiated with LACP, and the other is Layer 3 Ether channel negotiated with PAgP. The letters SU mean a Layer 2 channel is up and in use. Here it comprises two ports, FA017 and FA018. The letters RU mean a Layer 3 channel is up and in use. Again, there are two underlying ports, FA021 and FA022. Note, under the Ports heading in the table, P represents the interface participating in the Ether channel, and the letter I represents interfaces not participating. Take some time to read the output. The table on the slide displays other verification commands and their functions. Take some time to study it. Let us move on to the quiz questions to check your understanding of the topics covered in this lesson.